All right, this video we're going to go through a mock checkout on the float carburetor. Basically, this will simulate what I expect of you when you sit down with me and go over the carburetor. So essentially, I'm going to walk through this step by step so you have a rough idea on what to study to prepare for the checkout prior to reassembly in my course. This will be less polished for a number of reasons. One, we're not following a manual for this checkout. And two, I'm a bit under the weather. So I'm going to try to get through this and hopefully it's of use to you all. So essentially how this works is you're going to take your disassembled carburetor and you're going to bring it to me, including your parts, everything here. And we're going to sit down and I'm going to ask you questions about it. And you're going to walk me through how this carburetor works and identify the different components. All right, so let's dig in. First question I typically ask is, where does fuel enter the carburetor? For that, you need to take the top half of the carburetor and explain to me that the fuel inlet, which is right here, the fuel inlet fitting would thread into either this hole right here or the one on the other side. Okay, this carburetor gives you some flexibility as to where the inlet goes. So I can put the strainer in this way, in the fitting in this side, if that's how it needs to be set up on whatever aircraft it's being connected to, or the other way. Okay, so fuel enters through the inlet fitting and goes into this passage where it passes through the strainer. The strainer catches debris in here, and as the fuel goes out through the filter or strainer, it then comes down and out through the needle and seat. The needle's movement is controlled by the float. So give me a second and I'll pull out those pieces here. Okay, the seat is matched with the needle. That threads in to that hole right there. Okay, and I have my retraction clip and my float. The clip connects to the needle like that, and then my float will go in roughly like this. Okay, that's not going to be perfect because this isn't torqued down, but that's the assembly there. And then this would pivot via that shaft. All right, so then I might ask you, well, how does the float control that needle? And then you could explain that the float rides on the level of fuel in the bowl. As the level drops, so does the float, which allows the needle to drop down out of its seat and allow fuel to come in through that hole. As the level rises in the bowl, the float comes up, pushing the needle up into the seat right there, restricting the flow of fuel. So roughly the same level of fuel should always be maintained within the carburetor, whatever I set this to. So then I'll ask, well, how do you set the float? How do you adjust it? There's two different ways that you need to remember. I could have this tab, see right here, this gap. I can get a tool and bend the tab up or down. And since that tab is where it interacts with the needle, bending that tab up will move the needle up, meaning as the float rises, the needle will bottom out in its seat sooner, meaning the overall level of fuel in the bowl is maintained at a lower level. If I bend it the other direction, that means the float has to rise higher to push the needle all the way into its seat, meaning the overall level of fuel in this bowl will be higher. Okay? If I don't have this tab, the other method that is commonly used is to add or subtract shims underneath this seat. Okay, so instead of moving the needle further away or closer to the seat, why don't I move the seat closer or further away from the needle? So I can stack washers on the bottom before I torque this down, meaning the overall height will be taller, meaning the needle bottoms out in it sooner. Okay? After that, now we have discussed how fuel enters into the bowl. Once you're in the bowl, I'm going to ask you, what type of mixture control do you have? And your choices are going to be variable orifice, automatic, or back suction. If you have this is a variable orifice type. This hole or opening here is placed down into that sleeve, and as it rotates, the orifice varies in size. It'll get bigger or smaller. If it's smaller, I'm going to get less fuel, and I'm going to run more lean. If it's larger, I get more fuel, and I'm going to run more rich. Okay? If you have an automatic mixture control, you will typically find a set of bellows that sit down where this sleeve would be. And if you have a back suction type, you will typically find a needle and a lever mounted here where your idle mixture screw would go. Okay, so whichever you have, you will explain to me how that works. I will ask you about the basics on the other two. So if you have the variable orifice, we kind of explained that. It rotates and opens and closes. And I may ask you, what's the basic principles behind a air bleed type? And you're going to say, well, the mixture control varies the pressure differential between the bowl and the throat of the carburetor. Okay? If we vary that, we control how much fuel is actually drawn out into the airstream. For an automatic, you're going to say it has a sealed set of bellows. Those bellows have a set pressure inside of them that shouldn't change. As you take that and you go higher and higher in the atmosphere, the outside air becomes thinner and less dense, meaning the air sealed inside becomes higher pressure in comparison, making the bellows expand. As I come back down towards sea level, the outside air pressure increases, which pushes down on those bellows, and they squeeze. That expansion and contraction moves a control which will allow or restrict fuel to flow through the carburetor. If you have an automatic mixture control, you will have a redundant manual mixture control in case it were to fail. And remember, the automatic mixture control is designed to fail in the full rich position, meaning my manual mixture control I have as a backup can lean back from that and still give me control of my mixture settings. Okay, after we've gotten through the mixture controls, let's look at how fuel exits this carburetor. The fuel goes from the bowl down through the variable orifice sleeve, and it's going to come up and out of the main discharge. So I'm going to ask you, can you show me your main discharge nozzle? This one is stuck in there. Give me just a second. Okay, so with the main discharge, this end is where the fuel actually discharges. All these holes, you may have several around the outside, one in the center, there's different designs. But this is where your emulsion escapes. Okay, these holes below it are where your air bleed air enters the fuel stream and mixes with that to create the emulsion. And if we go down to the bottom down here, we have a tee off where the fuel can go up through your idle passage. And then at this end down here, we have your main metering jet. So there's a number of different operations that occur with this discharge nozzle. Okay, and if you look down into this hole, you will see light. So this hole right here intersects that. This piece right here is your idle jet. So again, main jet in the end of the actual nozzle. After it goes through that, fuel can break off and go up through this passage, through your idle metering jet. And then if we look at where this top half right here lays down on that, fuel will continue up that passage, and then you run into your idle mixture needle right here. Your idle mixture needle restricts that passage where your idle fuel is going, depending on how you need your carburetor to be adjusted. So if I run this screw in clockwise, I restrict that passage, making my idle mixture much leaner. If I back the screw out counterclockwise, then it's going to run more rich because the opening is larger. After I pass by that, I will reach these three holes in the bore of the carburetor. That is your idle discharge. So let's see. If this is assembled correctly, and if I'm at idle, this is pretty much all the way shut, only the top hole will be exposed. So fuel will exit or be drawn out by the low pressure created as air rushes around the edge of the blade. Fuel will be drawn out that top hole. As I slowly open my throttle, it will then uncover the second and third holes. Those other holes help create a smooth transition from idle range to the main metering range here. Okay, remember that we lose venturi suction, or we lose sufficient venturi suction to keep the main discharge functioning at idle, because there's just not enough airflow. But because the throttle is mostly closed and it creates a restriction of its own, we get that same low pressure signal, but up here. That's why we need two separate systems. You need an idle system and a main metering, because that low pressure signal that we rely on moves. All right, so again, fuel comes in through your mixture control, comes up, and then it can either turn up through your idle jet and through your idle mixture to your idle discharge, or it can continue straight up and out of your discharge nozzle right there. If you see this big hole up here, that is for your main discharge air. That's where the air comes in and mixes with that fuel. And then if you see the small hole here, that's where air mixes with your idle fuel. So in either case, we get an emulsion, okay? So again, you're gonna have to identify these different holes here. The one with the threads, or this brass jet, that's idle fuel. The one next to it, the small hole, that is idle air. The larger hole next to it is main air, and then the large discharge nozzle with the metering jet in the bottom is your main fuel. Okay, main fuel, main air, idle fuel, idle air, main fuel. Okay, I may ask you where your venturi is located. A lot of people like to point to the whole throttle bore. That's not correct. You're looking at the restriction, or the narrowest point. This right in here is your venturi, and I have two parts here. I have the main venturi, and I have what they refer to in different manuals as either the primary or boost venturi. Not all carburetors will have the center boost venturi, but it does help a lot depending on the application. So most of the time, when you're talking about these aircraft carburetors, you're going to find the combination of the two. I may ask you, what are these slots for on the outside edge of the venturi? That is where we take in the air that we use for air bleed and thus emulsion. So while air that goes through the center creates that low pressure we want, the air that is rammed into these outside holes here is captured and then routed through the carburetor. So that's how that air gets from here to those passages, which then mixed air in with my fuel discharge. It also vents it to the bowl to replace or to keep a suction from being formed as fuel is drawn out. And it also routes it up through your economizer passage here, because when we get to full throttle, the economizer, as we mentioned, will control that air bleed. Okay. Then I'll ask you, how does the acceleration system work? You're going to tell me fuel comes down through this hole in the bottom of the bowl, goes through this passage, and up through a check valve in the bottom of the accelerator well. This is your accelerator plunger. The accelerator system in general is used to give me an extra shot of fuel under rapid throttle movements, when there would be a temporary lean condition because the fuel would take longer to enter the airstream than the air that is already readily available. Okay, so to counteract that, when I move the throttle rapidly, this plunges down in the well where there's already fuel waiting. That increase in pressure closes the check valve at the bottom, so fuel can't come back into the bowl, and instead forces it through a passage in the side, up past this check valve here, the outlet side, and then out of my accelerator pump discharge. I'll ask you what the job of the two check valves involved are. I just explained the one in the bottom is to keep fuel from going back to the bowl, but the one in the top is to prevent fuel from leaking out all the time and to make sure that we build up sufficient pressure before that fuel is sprayed out. So it's not just dribbling out of there. Okay? What happens when this is moved slowly? Why don't we get an extra shot of fuel? Well, this isn't a perfect fit. If I move this slowly, one, fuel can seep past the edge of the seal and not be compressed, and two, whatever is compressed won't be of sufficient pressure to force closed the check valve, so fuel will just be pushed back into the bowl. Okay? And if I ask you what this hole is in the side of the accelerator well up here towards the top, that's for fuel to escape that gets on the top side of the accelerator pump. So if it retracts quickly, that fuel can be squeezed out of that hole back into the bowl to be recycled. Okay. I ask you about this. This is your bowl drain. If I want to drain the fuel out before I begin working, pull the plug out, and the fuel will drain. Okay. Now the economizer. I'll ask you, where is the economizer located? The economizer is located in this passage right here. Can you show me the economizer? Economizer in your carburetor is most likely going to be the needle air type. They have a spring, the needle fits in this housing. What position is this needle in below full throttle? It is in the open position. Why? Because air flows through that passage. Basically, the air comes in here, like we talked about, goes up, passes the economizer, and then goes down through those passages we talked about, where air is introduced to the main fuel and the idle fuel, and so on. Okay, so this is normally open. When I get to full throttle, the linkage that is connected to the throttle, this little tab, pushes on the needle and forces the needle closed. When the needle is closed, the air that we were using to create that emulsion is removed. making the engine run more rich or more inefficiently. But we need it to run inefficiently at that point because that wasted fuel is going to absorb heat from the engine and keep it from detonating or reaching critical temperatures. Okay? I'm going to ask you where your throttle valve is and throttle shaft. Here's your throttle shaft. The throttle valve fits inside of the shaft, and that fits in to the top half of my throttle body. I'm going to ask you, where would I find my idle speed adjustment? Okay. You can place the throttle shaft in. Show me that the screw, which is right here, my idle speed screw would thread into this hole here, and the further I run it in, the more it pushes the throttle open, meaning higher RPM. So if I ask you, if my idle RPM is too low, which way would I adjust the screw? You're going to tell me clockwise. If I run it clockwise, threads in more, like I said, pushing the throttle further open. Okay. Then I may ask you, which do you adjust first, idle mixture or idle speed? Do I go through the trouble of adjusting my idle mixture or the speed first? In general, mixture first, because mixture will affect your speed. If I can make the engine run more or less efficient by adjusting how much fuel I mix with the air, that will affect RPM. So if I adjust this to where it's spot on, my speed, then I adjust mixture, I have to go back and adjust my speed again. Okay? Here's another item, if equipped, the bowl vent strainer. I'm going to ask you, what is this for? What's this strainer for? That goes right here and filters the air that we use for the air bleed, for the emulsion, for the bowl of the carburetor. Okay? Not all carburetors feature this, but it does help get some debris out. Okay. Now, that may not be everything that I ask you, but it is the vast majority of it. I've tried to do everything right here off the top of my head, so there's a chance I missed something. But between what you've learned in lecture, what you've learned disassembling this carburetor, plus this video, you should be more than ready to answer questions on how this carburetor works. Oh, there is one more. How would I check a float for a leak? Well, you can submerge it in hot water and see if bubbles come out if it's a hollow float. With a composite float like this, I could submerge it in the water and see if it floats when I'm done, see if it's heavy, things like that. Okay, the float needs to float, otherwise the whole carburetor is going to be inoperative. Okay. After that, if you've passed my checkout, you will then be ready for the next video, which will cover reassembly, torquing, and finally adjustment. And then there will be only one more video in the series after that, which will be rudimentary testing of the carburetor. All right.